irrespective of the signal being analog or discrete, the signal is varying continuously. Theoretically, the signal can take an infinite number of values between 0 and the maximum value. Suppose you can have infinite number of voltage values between 0 volts and 5 volts. It becomes very difficult to represent values in your device with precision because the device has certain limitations. For example, your device may reliably only have the capability to store a certain number of digits in the fractional part of a number. So accuracy is a huge problem in analog systems. So what we do is, along with discretizing the time, we discretize the amplitude of the signal as well. So here, we are first going to discretize it in time. And then we are also discretizing it at the amplitude level. Discretizing the amplitude means that we only allow the amplitude of the signal to be in certain levels. So, when we process the signal, we process the signals at those discrete levels. This type of signal is known as a digital signal. So a digital signal is a signal which is discrete in both amplitude and time. So to improve accuracy based on application, you can increase or reduce the number of levels that you want. For example, I can say that for a voltage signal varying between 0 volts and 5 volts, I will have 2 levels. Let's say level 0 and level 1. And now I will say that level 0 indicates that the signal is not present, that is 0 volts. And level 1 indicates that the signal is present, that is 5 volts. Now this is a very crude way and it is very inaccurate, but this is how we proceed. And another way that you can say is 0 level indicates that the value of the signal lies in between 0 and 2.5 volts. And level 1 signal is nothing but a signal whose value lies between 2.5 volts and 5 volts. This is a much better way compared to the previous one, but it has its own inaccuracies. So accuracy in analog system depends on the instrument capabilities and they may degrade over time. Digital signals also have inaccuracies as previously discussed. To improve accuracy, you can have 4 levels for a signal that is varying from 0 to 5 volts. So I can have level 1, level 2, level 3 and level 4. So I'm going to say that a signal is in level 1, or you can start with level 0 as well. It doesn't really matter. So let's make it 0, 1, 2, 3 for consistency. So a signal whose value lies in between 0 volts and 1.25 volts at an instance of time that you're measuring, then I'm going to say that the signal is in level 0. If the amplitude of the signal falls in between 1.25 volts, 2.5 volts at an instance of time that you're measuring, then I'm going to say that the signal falls under level 1. And I keep going. So if the signal falls in between 2.5 volts and 3.75 volts, then I'm going to say that it's a level 2 signal, and 3.75 volts to 5 volts, then it's a level 3 signal. So as you can see, compared to having only 2 levels, having 4 levels provides us with better accuracy. So the more the number of levels you have, the more accuracy you can get to represent the signal and process the signal and store the signal. So digital domain offers this flexibility, which is clearly lacking in the analog domain. Digital signals are much easier to store, transmit and manipulate without much error. For example, let's say I have an analog signal and I want to transmit it to the receiver. As the signal goes through a channel, noise gets added to it. So let's say if the original signal value is 1.5 volts, assuming that it's an analog signal, and we send it through a channel, and the channel is going to add 0.02 volts. So the receiver might get a signal which has a value 1.52 volts if noise gets added constructively, or it can get 1.48 volts if noise gets added destructively. Therefore, the receiver has no idea how much was originally sent and how much noise was added. Of course, there are some noise filtering techniques, but they have their own limitations. Now let's take the digital domain. Suppose I have a signal which can vary from 0 to 5 volts, and I'm using 4 levels, which is consistent with the one that we have here. Now, let's say I'm trying to transmit the same signal 1.5 volts, which basically falls under level 1. So it goes through the same channel, and let's say assume 0.02 volts of noise gets added. It can be either constructively or destructively. So you either get 1.52 volts or 1.48 volts. However, you are still in level 1. Of course, if you have, let's say, a signal at 2.5 volts, which is level 1, and it goes through the channel, assuming 0.02 volts is getting added, so you might end up with 2.52 volts. Now this can be a level 2 signal. I'm not saying that digital signals are perfect. All I'm saying is they have much better performance when it comes to noise. So in this way, your digital systems are much more reliable than analog systems.